Yeah, good evening, all. Okay. Today's our topic is machine learning. So, by using Python, how to build a machine learning? What exactly the machine learning? It's a current booming technology. Everyone preferring machine learning in so many of the companies are being they want to implement the machine learning techniques in their softwares, everything. So, we'll see what exactly the machine learning and types of machine learning algorithms. So how we are going to apply an algorithm and what is the necessity to applying, and where we are using in a real time application, and the process, the step by step process of learning skills which will improve the writing a code in a machine learning. And then libraries, the what are the required libraries we require to build a machine learning, and what are the commands how to build a software, the libraries in a Python we will see. So basically for this machine learning tool we are using a Jupyter notebook or either Anaconda Navigator. Okay, these two are the best tools. I request to those who are want to working with a machine learning, I'll suggest these two softwares. So if you are telling about machine learning, it is a beginning stage of machines are being learned. So it is a subset of an artificial intelligence. All of you know that. So what is an artificial intelligence? Which will mimic the human brain. So if you want to mimic the human brain, what is our main requirement? If you want to mimic, what is the main advantage of humans? He can able to think, and he can able to predict, he can able to guess the answers. I mean, he has so much of knowledge is there. So these things we have to give initially the things. So that's why the machine learning will do this kind of thinking behavior to the AI. So that's why we are calling it as a AI is a subset of machine learning is a subset of AI. So in AI, we have the different kinds of fields like IoT and then machine learning, deep learning. All these are the subsets of an AI. So today we are going to discuss about completely machine learning techniques, how we are going to apply. So every scientist they are giving us some different names initially for the machine learning. Arthur Samuel is the father of a machine learning. Initially, he was introduced to machine learning in 1959 with a collaboration of an IBM. So, the IBM first introducing the technology called machine learning. The field of study that known as machine learning is concentrated with the questions of how to construct a computer programming language that automatically improves with experience. So all we know that simply, if you are, let us assume, so how we know if it is going to be night or it is going to be early morning, or if you see any object you just directly give your name, right? This is an apple, or this is a pen, this is a fan. Likewise, if you are seeing any object you can able to answer the questions easily, and even you can able to predict the future, like if it is going to be 5 to 6, it is going to be night, you are easily understanding by seeing the time itself. So how you are predicting the simple future, the before experience, how you are predicting, because it's not happening in a single day. So you are already experiencing the future, I mean past. So based on that past experience you are predicting the future, right? If you are feeling it is a hot or it is a fire, so how you can able to get it? Already you are experienced that, or somebody will teach you, either experience or teaching or learning. So these two things should be happen. So machine learning is an application of an AI that provides the system ability to automatically learn and improve the from experiences. So the machine learning, which is we are giving an inputs, so based on that learning it can able to perform. So machine learning focusing on developing of a computer programming that can access the data and it can learn from themselves itself. So in this programming language, mainly set based on the three things. One is a learn from the experience with the present of some class of task and performing the measures P. Okay, let us take a small example. I'll tell you the hand recognition learning programming. So problem. So whenever if you are writing the particular writing, it should be recognized. So our first task is recognizing and classifying handwritten words with an image. Okay, that is our main task. So now we have to perform present of words correctly classified. That means if you want to give this all these things should be properly predict, we have to give the experience, a set of data set, we have to give the handwritten words which is given in a classification. Simply we can tell it as a data set. Okay, so the data sets plays a key role. Or if you take another example, robot driven learning program. So in robot driven learning program, the driver and the highways using a vision sensor. Vision sensor is nothing but camera, we can tell it as a camera. So the average distance traveled before an error, that is our experience, that is the tasks to be performed. Okay, and now what we can able to do. So how we can do, how our machine can able to understand this kind of problem. A sequence of images and streaming commands recorded with a observing by a human device. So you are, let us assume you are driving on a highway. So how you are suddenly did the brake, you are, if you are experiencing some object or if you are experiencing any speed breaker, so all these things. So now we have to give some input images to our machine learning things, that we call it as a data set, and in the form of model we are given. Okay, one term model it is come, we will discuss it later. So model plays a key role in a machine to build a machine learning applications. We have to build our own models. If you want to build, if you want to train any algorithm or if you want to do anything, it is the main. Okay, and mainly the basic components to learning process is learning process whether by a human or a machine. So we'll compare these two, can be divided into the four components. Either human, if you want to predict anything, you are depending upon four parameters. One is data, second one concept, third one interfaces. So in a system way we can name it as a data is nothing but data storage, abstraction, generalization, and then evaluation. So these four concepts we are taken. So let us take a data storage. So facilitating facilities of storaging of retrieving the huge amount of data, nothing but let us take an example, weather prediction. So you want to predict the weather majorly. So if you want to predict a weather, what is your requirement? First you require your data, you have to collect the past data. So the learning doesn't happen within 1 or 2 days, you have to give so much of data with that if you want to improve the accuracy of that particular algorithm or a particular machine. So most of them we are thinking while working in machine learning techniques, we are thinking that uh, the machine learning mainly on what algorithm we are taken. It's not like that. Which algorithm you are taken in a machine learning, not an issue, but which data we are given, that is a main aspect. How much data we are given. If you are having so good storage of data, so then you can able to good memory power, then you can able to answer any kind of question. So the data is a main aspect here. So in a humans, the data is stored in the brain or a data is retrieving by using electrochemical reactions in our brain. If you want to retrieve any data from our brain, the electrochemical reactions are being done. So in a same way, the same similarity should be done in our algorithm. So how it will be happen? We are storing all the data by using hard disk or flash memories or RAMs or random access memories. All these kind of things we are using. And if you want to retrieve the data, so then we are using some USB cables, or all these kind of things are to retrieve the data we are using. And then second stage, so data collection part is over. The second stage is abstraction. So in abstraction, the second component of the machine learning is known as abstraction. So the abstraction is a process of existing knowledge and storage data. So already we are storing some data. This involves creating a general concept about the data and the whole. The creation of the knowledge involves application of a known model and create a new model. So again the model what came. What is this model? So if you want to train any algorithm or anything, don't think algorithm means it's a big thing. If you want to working with a Python, it should be a simple thing. If you're after working that, let us assume you buy a new mobile, and now in that mobile you have one feature called face recognition technique. So now what you will do, whenever the face lock system you want to keep, then what you will do initially, you train your images, right? So 100 images you are trained clearly, so then only your device can uh, able to understand. So that is nothing but model training or input data we are call it here. So 1 to 100 images we are continuously giving, and it will be stored in a one in your data. Okay, we are storing that data. So you are giving some input information, it is stored in a ram or anything, and then it will created a one model, and that is called trained data set. So whenever you are taken giving any input data set, that is nothing but fast, if you want to face scan initially, if it is matched with the input image with the data set image, then it will consider it as a face match, and it will open the door, I mean the lock, face lock system will be open. Otherwise it will show you unknown person is trying to, it will not open the lock. So how it will, the machine can able to understand. So the prediction, so this can be done by the prediction and then abstraction. So first we have to give the build the model properly. That means we have to train our images properly, otherwise it will show you inaccurately. With your sister also, the lock will be open very easily if the similar face is there, yours with your siblings or anything. Okay. And then second third thing, generalization. The term generalization described from the process of turning knowledge and about storage data. In general, the goal is to deserve the property of this data. Like we have a different kinds of properties for everything. Like take same the example face recognition. So it will not recognize all the faces. We have some features like the face recognize, it should recognize only face, not all any object. So for our face we have the separate features called generalized features, eyes, nose, mouth, chin, all these features we call it as generalization features. We have to, it will train. Even generalization features also we have to train. Okay. Are nothing but we call it as a labels. Okay. And then evaluation. So the last stage of the process in a machine learning is the evaluation techniques. In the process of giving feedback to the users, so that is nothing but we are going to compare with the already trained images and the input image. Not only image, you can take any data. We are not generalizing. I'm in application of an image, right? So that's why I'm telling it is an image, but it is a generalized. You can take any data, even if you want to weather prediction also. It should having some past data set. Then only it will give you the accurate, more accurate. The feedback is utilized to effective improvements of the whole learning process. Okay, and then we'll see some applications. So the applications of the machine learning methods to a large database is called data mining. We call it as. In data mining, a large volume of data is processed to construct a simple model, which with valuable us. For example, we are having a high prediction accuracies. The retail business we can use it. Stock market predictions we can use it, and banking analysis like credit card fault detections we can able to achieve, and then medical applications. Recently, we are even forecasting the. I mean, we are predicting the COVID-19 cases also by taking the past experiencing cases. I mean, we are comparing with the previous data sets already affected people. they may chance to how much people we can able to predict easily in healthcare sectors and telecommunication sector. So all these are some applications, even some website Netflix. You are searching for something, it will give you the prediction. Okay. Or regularly we are searching for one series or anything. If you are type two letters, it will give you the next suggestions. So all this followed by the Netflix and the Google. So it will automatically train. So we call it as a uh, you are input taking it as a trained data set. We are not initially give any trained data set, automatically it will collect your data. So after collecting your data, it should converting into the model, and it will compare to the, you are going to give a future input also. Okay, so that's the Netflix will work. Movie recommendations it will give you. If you are searching for a one series regularly you are following, just type the starting letter, it will give you the series. And then Facebook, it will give you friend requests, right, friend suggestions, and tags friends faces. Like it will automatically sometimes it will name tags, it will give you in our photo drive also, in our phone galleries also. Now it is giving people, one people option it is given. So similar people faces are in one folder. So how it can be? By using machine learning techniques. And fraud detections, like a pay call, they are telling fraud detections how many are going to so easily can fraud, if the similar features are having, they are going to do the fraud, all these kind of things. And then the real time application, Uber, they are using Amazon, FIFA gaming, and some other application. We are virtual reality, we can implement the machine learning technique. And gesture control gaming. So in a Uber, how they are utilizing, how they are predicting, suggesting some drops and pickups in automatically. So if you are searching for one day you are booked an Uber, so it will give you a drop and pickups automatically. The second day also it will give you the suggestions, right? That is called training. If you are continuously frequently using, it will give you the accurate. It may be initially, it may not be, but if you are trying to again you are doing, it will train automatically. And Uber shares find customers traveling in a similar routes, like those who are traveling sharing, and allocating the booking pass based on the time, distance, price, and rates. Like 1 kilometer you want, you are giving the starting point and destination you are giving. So how much time it will take, it will predict, and how much distance it will predict, and including cost also. So how it will predict the cost, even the time or a distance means, it will based on with respect to time it will give you the distance, or with respect to time distance it will give you the time. But how it will predict the ratings, price and ratings means, price means uh, previously that person, those who are using Uber, he will travel in this particular location, they may expect the same cost, so that's why it will predict you the cost. And types of learning. So basically we have in a super two kinds of learning, three kinds more, totally we have in three kinds. One is supervised learning, unsupervised, and reinforcement learning. So reinforcement is not, now we are using basically currently most of them are focusing on supervised learning, either unsupervised learning. So before discussing the supervised and supervised learning, we have to focus on the classification, the types of models. After this, I'll discuss. So first thing is classification. So in a machine learning, the classification is a problem to identifying to which set of categories new observations believing on a based on a trained data set and a observing instance. For suppose example, consider the uh, two persons scoring, like score 1 and score 2, let us assume, and the results of score 1, I'll take two parameters 29 and 22 for score 1. For score 2, 43 and 29. Okay, so these are the four marks. So those who are getting 29 and 22, one subject he is passed, another subject he is failed. Just draw it in a paint, then you can able to understand easily. Wait a second. Okay, now I'll take an example for the classification. So how it will do the classification and all. So let us assume this is a score 1 and this is a score 2. Okay, it is 2 persons, but I'll consider it as a score. So I got 29, and this score 2 consisting of 43, and here it consisting of 22, and then 29, 10, 47. Okay, so here it will give you pass, and then it will give you fail. Okay, we are all so in a classification or in a machine learning, we have to initially give the results. Output also we have to define. So here I given, even I gave the results itself here. Okay, the score 1 is 29 and this is a 43, so it will give you pass, and this is a 22 and this is a 29. I gave here we gave the results fail. So that means what, the machine can able to should understand the classification. uh, those who are more than 29, it should consider it as a pass. Those who are getting less than 29 in any subject in a two scores, if anybody got this problem, so then it will consider it as a fail. So it should automatically understand based on these results. If you are giving a new score, a score 1 is a 18, and then 50 you given, it will give you the answer fail. Why? Because it is already, we are giving the inputs parameters here, the score 129 and 40. That means the minimum, if you want to pass any subject or anything, we should have a pass mark 29, it should be must. So it should understand, and in a second time it will give you, if you are giving a input parameters, then it will consider it as a fail. Why? Because the input, here I'll take it 18, here I'll take it 18, and then 47. So now the machine should predict this result. So these are the data sets, all these are the data sets, this is an input. So here I already gave the results. Based on these results, based on these data, it should predict. So if it is giving accurately, if you are giving the data, so then it will give you fail. Why? Because 18 in one subject he's got a less than 29. So these kind of things, or these kind of algorithms we have to give. How it will be done means by using different kinds of algorithm. So this is called classification technique. So this process we call it as a classification. So under classification technique we are also, wait a second. So here the supervised learning. So the classification is one of the best example, here is supervised learning. In supervised learning, you train the machine using data which is labeled. So we are already labeled, right? Score 1, score 2, and even we gave the results. It means some data is already tagged with the correct answer. We already tagged with the correct answer. It can able to compare to the learning, that is inputs parameters, it is called supervised learning. That means in a supervised learning we have a teacher. A teacher is presented which will train us. So here if you are taking in this example known data, so this is already stored in a particular model. So this is apple, and these are some unknown known response. So we are given this is a data, known data, we are tagged this is an apple, we are trained this model. So now known data and unknown data we are given. Now our machine should predict it's an apple. So how it will detect? So based on this known data, if it will compare the known data with the unknown data. If it is the features are matched, the labels everything is matched, then it will consider it as a apple. Okay, so this we call it as a supervised learning. In supervised learning, teacher is there. This is an another example. Let us take the, this is labeled data. So that means for every circle I labeled it as a circle, for square I labeled it as a square. For everything I just give the some squares or circle or triangle, I give it to the I trained the model. So this is the model, I trained it, I apply algorithm and I trained it. So now I gave the new data, that is nothing but one square and one triangle, circle I gave. So now it should predict this is a square and this is a circle. Some real-time applications for the supervised learning is optical character recognition, a face recognition technique, speech recognition technique, and medical diagnosis, and knowledge and extractions, and then comparisons. So if you want to compare anything, that is a comparison classification, it will come. Under the supervised learning, you can expect the logistic regression algorithm you can apply. Under supervised learning, these are the application algorithms you can apply: navi bias application, and knn algorithm, and then decision tree algorithm, and support vector, and random forest algorithm. So these are the algorithms which are presented under supervised learning. And here over, what are the main remarks in a classification techniques is, the classification problem requires that examples to be classified in one or more classifications. That means we have to clearly train our model. That is one problem. And the problem with the two classes is too often two classes binary things. We have to like the similar projects. If you are not properly give any input, it they may chance to get a output if it is not properly able to classify. And then regression techniques. So in a machine learning, the regression problem is the problem to predict the values of a numerical variables and based on the observed variables. The value of an output variable may be number or an integer, or it may be a float, or often qualified it as a amount of size, and the input variables and may be a discrete or any real time. It's not an issue. Okay, in regression technique. In unsupervised learning. So if you see the classification techniques in unsupervised, I mean in a supervised learning, we have a master is presented. That means we are already give some instructions. According to that instructions, it will just check it is correct or not. Otherwise, it will give you the output. But in supervised learning, we don't have any master. So there is no teacher is presented over here. Based on the past experiences, it will understand unlabeled data we have to give here. For suppose this is my input data and model, and it should have to predict. Okay, here I have a different data. One is guava and apple and then mango. Three are there. So how it will classify? So we are giving input data. So now in a model it will give this is an apple, this is a mango, this is a guava. It will identify. How it will identify means all red colors is coming to one grouping. It will do the grouping techniques. Okay, the model will do the grouping techniques. And then if it is in a yellow color, then it will coming to the mango and then guava. So all these three it will considering into the one by one. It will check it. If it is similar to this group, it will make it into that group. And this will likewise it will groups it will do. It doesn't give the any name, this is an apple or this is a mango or this is a guava. It doesn't give any name, but it will identify and it will make it to the groups. So here also the same example, unlabeled data we are given, and it will give it into the different kinds of groups like circle and then square and then triangle. It will give you. So how it will give you the same featured things are in a one group and same features are in a one group. Likewise, it will make into groups. Okay, so now we'll see the process how to build a, what are the parameters we require and what are the some things we require. First we need to the process. If you want to apply this theoretical knowledge into the practical, we have to require some data. So first what we need to do, if you want to train our model, first we have to collect gather the data, and then data processing we have to do, and then model selection. So which model we want to apply, which algorithm we want to apply, and training and testing the model, and then evaluation. So already I tell theoretically like abstraction, generalization. Likewise, we have discussed it theoretically, but in a practical, how we can collect the data, where we can collect it, we will see. If you want to apply practical data, I already tell about data. I don't discuss. So where we can collect this data in a Kaggle website or UCI machine learning respiratory, we can use this too, and you can collect so much of data over here. Or else by using some IoT devices, you can able to collect the real time data very easily. If you want to work with the real time data like temperature, pressure, all these kind of things are the real time data, you can collect it from there. Or already some default data set is presented in the Kaggle website, you can directly download it over there. Okay, and then data pre-processing. So now the data pre-processing is one of the most step in a machine learning. It is a most important step that helps to evaluate the results. So the data processing will do, if suppose you are taken 100 in an Excel sheet, you are taken 100 attributes, I mean 100 data you are taken. So in some data is missing, in between some data is missing, or some data is zero. So all these things are should be eliminated, the empty value should be removed. So all these kind of things are clean up or cleanly watching by using data processing. Data pre-processing is the process of cleaning the raw data, that is data is collected in the real world and it is converting into the clean data set. In other words, when the data is gathered from the different sources, it is collected to the raw format, or it may be a fusible, it's not be doesn't be fusible, feasibility for analysis purpose. So we have to um, pre-process the data. All the attributes should be there, there is no spaces in between the attributes, and it should not be null data type, and all the data should be in the same format. The if for suppose score, previously we'll take a one example score, right? 29, 30. So while doing data processing, all the data should be in integer, not in a float value, or all the data should be in a tuple, not in a list, or it may be a list, but the sequence of order should be same, or everything should be in a same manner. So all these things are being done by using data pre-processing. why do uh, why do we can need it? So as know that data processing is a process of cleaning the data. So the reasons is noisy data, and then missing data, and inconcentrated data. So and some human errors are can be there, duplications are can be repeated. So all these things should be eliminated by using data pre-processing. And what is the machine learning model? So now a machine learning model is nothing but a piece of code an engineer or a data scientist should make it smart through the training with the data. So for suppose you are trained hundreds of images. If you want to store that hundreds of images in a data set, or if you want to give it to the algorithm, so much of the data should be very high, the huge data we can't able to give. So if you are decreasing the memory and compress the data we are given, and it will give you the accuracy, the training model will provide false or wrong predictions. Okay, if you are not trained the model clearly, then it will give you the wrong predictions. So we have to clearly focus on while doing prediction modeling, either we are giving proper input or not, we have to make sure proper data we are not given. So generally the purpose of the modeling is a model, either it should be a to compress the data very clearly and to apply the data for that particular model. So our main goal is to train the best performance model possible using the pre-processed data. So already we are taking some input processed data. These are most of the classification algorithms like KNN, Navy bias, and decision tree are random forest. Both are the same. And then support vector machine, we call generally we call it as SEM, and logistic regressions, and these are linear regression and support vector regression, and K means clustering. So now we will see the practical thing. I already have some temperature data. How we will predict it, we will see. I just go to the Jupyter notebook. Okay, it is opening the model. So this is my code. I just directly import the entire folder. So I have test.csv, test dataset, and this is the input to build a model, data collected, and then this is the main code. Okay, I'm going to upload all this. Okay, so here the first step we have to do in the building and any coding in a machine learning or any Python, we have to import the necessary modules. If we are supposed to working with a C language, we are using hash include the libraries function. But here in a Python, we are call it as a modules. So now we have to import that modules. So import the necessary modules. So I'm importing first thing Panda. So then pandas will help you to read the data set. Okay, like CSV file or this kind of formats, it will help you to read the data set. And then NumPy. So NumPy is for mathematical calculations. And then matplotlib to plot a graph. Okay, and then import cborn. So the graphical representation, if you want to with a matplotlib, the cborn also be required. And then now if you run the cell, it should not give any error. So it will come into the next line. If it is giving you any errors, called no module found errors, basically it is given. So that means you are not the modules are not presented there, so you have to install the modules. Okay, and then data is equals to pd dot read csv. So now I have to read the csv file. So what is presented in the csv file? We just go and see in our code. So this is my code. One csv format excel sheet is presented there. Okay, so here it is a time. Okay, created with a particular time, how the data is processed, and number of entity IDs. So how many attributes are presented, and the temperature with respect to this particular time. What is the temperature? 32.73 like this. So now here I take the target. So now we have to give the this is a supervised learning. In a supervised learning, what we need to do, we have to already gave the results also. Here I gave the results called, if the temperature is greater than 30 degrees, that is a maximum. If the temperature is greater than less than 30 degrees, then that is a minimum temperature. So now I want to predict the future of my room temperature. That is my main aim. So with this is a temperature attribute, and then this is a target. The target is nothing but we have to predict. So the results also we have to give in a supervised learning. So here I go with a supervised learning, nothing but random forest algorithm I am going to apply. So I'll tell you how to apply. First step we need to do is the data pre-processing. Okay, so this is my data set. I just give this is a feed 5. Okay, this feed 5, yeah, this is, so here in a feed5.csv I just imported the entire file using which library, which module, pandas module. Pd is nothing but panda. Pd.read csv, the file name I given. So I successfully read the data whether it is imported or not. We run this cell, so then it will give you. And then print data, so I just give the print data, so then it will give me 83 rows and 4 columns, entity id, temperature and target, which is shown similar in the excel sheet. So the similar things it will give me. I just imported into my code. And then data.head to display the first 5 parameters. So now I'll take some separate data. First 5 data, data.head. So data module, I mean data is nothing but our data. This is data variable, right? This is data. In this particular data I am going to take the first 5 parameters. Okay, it will print the output. So this is the fourth line. The fourth line output is this: 0 1 2 3 4, the entity creating id with respect to particular ids. Okay, and then target, minimum and maximum, and type of d, underscore in a frame it is given, and data dot shape. So if you want to, the data dot shape will help you if you want to know any how we can tell it as number of rows and number of columns presented in that particular excel sheet. It can be defined by the data dot shape. And then data dot info. So the data dot info will help you to check each column data type. So like initial I'll take the first zeroth column is a object, and then first column is a integer value, and the second column is consisting of float. Second column is nothing but what, temperature column, 33 point, like this we have. And the target is a object, it is completely like a string, so string we call it as an object here. And now I want to plot process the data. So I take another variable called temp is equals to data temperature. So I just print this. I want to plot a graph with a marker 0. So all the points I need to point out all the parameters like 23 degrees, 0.63, like all the points I need to plot on a graph with a color of green and with a marker 0. And the line length should be 0. I just give the line length initially 0. See, I plot the graphs with respect to y-axis. So the y-axis is the temperature parameters, and 0, 20, 40 is the seconds. So now I want to, by using Seaborn, I want to plot a graph. The bar graph I drawn here. Okay, and then from sklearn pre-processing import label encoder. So convert the object into the numerical type. And then after I import the sklearn pre-processing import label encoder. So that means we are going to import the packages. Actually the algorithm means lot of mathematical calculations, but as of now we don't need to all those things. We just directly importing that third party libraries, some modules, it will help you. Okay, like you just directly import which algorithm you want to use. Just know that name itself is enough. No need to, just basic overview you required, not a in-depth calculations and all, you no need. So if you want to suppose to working with that. And then data is equal to new target. So now I'm going to test all, take the targets, converting the targets. That means 0 and 1. So all these targets are in an object. So now I need to converting into the integers. So the maximum value I take it as a 0, and minimum value I'll take it as a 1. Okay, so now the target will be converted, and this is the target and this is the new target. So maximum equals to 0 and then minimum is equals to 1. Okay, Minimum means less than 30 degrees, that is a minimum. Greater than 30 degrees, that is a maximum. And then data is equal to, we don't want all the columns, we required only the entity IDs with respect to temperature and the targets. Remaining things I just removed by using the function called drop function. So in a drop function, which parameters I want to remove? Create data, entity ID, and then target. I required only either temperature and the new target. So I need these two parameters. So now separated the data into the two arguments. One is x data and then y, that is nothing but target. So already we predefined the targets, right? In the machine learning, we have to train the, we have to give the output also. Pre-results also we have to give. I already gave 0 and 1, 0 and 1. Now we have to pass, call the algorithm. So here I don't want, I want to use the random forest classifier from sklearn.mbuilds. So sklearn models, so sklearn package I have to import random forest classifier. Models is equal to random forest classifier. I just import the, in a model, I want to build a model now. um, the entire classifier I import into the model. So now which parameters I want to build? X and y axis. So I already drawn the model, right? X and y axis with respect to um, temperature and the IDs, entity IDs. And then I got an output classification. So minimum. Now it is trained, the model is trained. So now I have to give an output. Okay, so here I gave an input, enter your manual data. So here you have to add our manual data. Like I gave 29.9, it gave me, if I run this now, okay, we'll run from here itself. Wait a second, we'll delete this cell. So now for this input model I have to predict. I just copy and rename it. Still it gave me the error. Once we check it, whether the model is imported or not clearly. Okay, so we have to go here and we'll run this. So now it is imported successfully, the random classifier. So you entered a minimum room temperature. So if I given now 30.29, okay, 30.2 I gave, 29 I gave. So now it will predict an output maximum room temperature. So based on that user input, it should be give the machine itself predict, not we. The machine itself it is predicting, and the predicting the accuracy, the algorithm accuracy we need to found. If you want to found, so then the accuracy of my algorithm is trained data set is 1. It will give me. Okay. So I just import this predict dot result predict data. Okay, so this is all about this machine learning, and then temperature prediction we did. Had any queries on this entire session, please ask, all the questions in a comment section. I'll try to solve your doubts and everything. Okay, so here finally after applying algorithm we got the prediction. Okay, we got an output like entered maximum room temperature or anything. So now this is the, we required the accuracy of the algorithm. So reading a test data. So the entire test data we are taken. That means already in a folder I gave some test data, right? This is test data. So in this I take some data in the particular feed, my particular input, and then save the temperature in a particular data, and then saving a target variables. I'm taking new targets, converting into either 0 or 1, predict the results, giving the test data to the model. So this is my test data. I take some parameters, test data results. Yeah, we shared the feedback link in a comment section. Let us check it. Already we shared it. Go through that. Any questions on this entire session? Please ask. Any queries? Thank you all for your patience and happy learning. Thank you all. If you want, you have to fill the feedback form. Then only you can able to get your certificates. Okay. Please everyone fill the feedback form properly and submit it. Thank you all. I hope all are enjoying this session. Thank you very much.